Alright guys, I want to go over a few different examples that you will see on Unit 1 worksheet number 4. You are solving for a singular variable, and you'll be instructed on which variable to solve from there. Now, when you get the worksheet, there's all different types of variables and all different types of equations, but you'll be told which one to. So for instance, in this example, and we can see that this is the area of a triangle formula, they asked me to solve for the height. Now, there's two things to get rid of, the 1/2 and the base, b. They are both being multiplied times h. Now, I typically like to get rid of the 1/2 first. And you could talk about division by 1/2, which a lot of you will do, but I suggest maybe that you multiply by the reciprocal. If you multiply by the reciprocal on both sides, that 1/2 and that 2 disappear. And so now I'm left with 2a equals base times height. And if I'm trying to get height by itself and it's being multiplied times the base, then I would divide by the base to get rid of that, and then I'm done. A equals 2a over b. So, a couple easy steps. Some of those questions on that worksheet will be as easy as that. Now, the next one that I have here is a little bit more complicated. That's why I'm bringing it to your attention. Remember in examples like this where you have 2x equals 5x minus 7, we would want to get the variables on the same side. Well, the cool thing about this is every term that has an x in it is called a variable term. Now you're probably saying to me, well, why can't you call the c over here a variable term? Because it doesn't have an x in it. Now, if you ask me to solve this equation for b, then this would not be a variable term anymore. This would be a variable term, and this would not be a variable term. So, depending on variable terms, must have the variable you are solving for. So the question I have for you is, are the variable terms on the same side? The answer is yes, definitely. So that's easy here. That's good. Now the next move that we're going to do here is not something you would normally think of. So I definitely need to show you. What do these two terms have in common? Answer, they both have an x. So we're going to use the distributive property, but we're going to use it backwards. We're going to pull out what they have in common, which would be what? They have that x. We're going to pull it out. What are we left with? Well, in this term we're left with an a plus, and in this term we're left with a b equals c. Now x is being multiplied by a quantity. Kind of like if I had brought this over here, I would end up with negative 3x equals negative 7. What would you do in this next example? You would divide. So, we're going to do the same thing here, but what are we going to divide by? We're dividing by a plus b. Now, there is nothing magical about these parentheses that I'm putting around the a plus b. The only reason I'm doing it is so that you understand that a plus b is one thing. It's one thing that you're dividing by. It's just got two parts. You're dividing both sides by it. So that whole thing is disappearing. Don't tell me that the a's are canceling out and the b's are canceling out. That's not true. The quantity a plus b is canceling out. Just like if you were over here and you divided by negative 3, the negative 3 and the negative 3 are disappearing right there, leaving me with just x equals 7/3 because the negatives cancel. But anyway, so you're dividing by a quantity a plus b. So the questions get a tad bit more complicated. I see that there are x's on both sides. I also see that I'm going to have to do some distributing. So we're going to distribute here and here, giving me ax minus 3a plus 8 equals bx minus b. Now, Which one are the variable terms? Right here and right here, those are called the variable terms. Here, here, and here, these three are called constant terms. So we have variable terms and constant terms. We need to rearrange that so they're all together. So I'm going to obviously push the bx to this side. Well, I should say obviously because I'm choosing to put the bx on that side. So I would subtract it over to the other side. And if I subtract it over to the other side, I would have ax minus bx. Sorry, I need to push that up a little bit. Now I'm going to move the constant terms to the other side. So I'm going to add the 3a to the other side. I'm going to subtract the 8 to the other side. And of course I already had negative b over there. You can have those terms rearranged however you want. It doesn't really matter. What do these two things have in common? They have the x in common. So I'm going to take the x out. Not to dinner because that would be very awkward. I mean, we don't get along that well. So 3a minus 8 minus b. Divide by both sides. What are we going to divide by? We're dividing by the quantity a minus b. Like I said, these parentheses aren't magical or anything like that, but it's just helping you understand that those two things are canceling out. So this is x. Kind of ugly. The things in the top can be rearranged. They don't have a particular order. So we had to distribute. We had to move terms that were alike to the appropriate sides. And then we had to factor out the common x. And then divide by what was being multiplied times x. Okay,